Couchbase. What are we customizing? Who are our players? What did we actually end up using at the end of the day? And why did we pick Couchbase? But before we get there, just who is we? What are we trying to do? And who am I? So my name is Clinton, or Kenton, as they tried to write it on the Starbucks cups over here. I work for a company called Derivco, which is based in Durban in South Africa. I've been there for quite a long time, 16 years. I'm currently in the Horizon team. Now that's a weird sounding name, but it used to be called the Solutions Architecture team. We went through a bit of a rebranding a few months ago. But it's quite a nice team to be in. We do a lot of R&D. We introduce new processes, new technologies, new products in the company. And when we have to get involved, it normally spans across different departments. So Derivco itself, we're hosted in South Africa. For those that don't know where South Africa is, as the name suggests, it's at the bottom of Africa. And if you zoom into it itself, there's a map of South Africa, and we're based in Durban, which is on the East Coast. Now, a lot of people would know Johannesburg and Cape Town, since that is where you go to do business or go for holiday. So Derivco itself started in the mid-1990s. Usual startup company, 2-3 guys in the garage. We have over 2,000 employees now in over 7 continents. We are the world's oldest and first provider of online casino software. So we do casinos, poker, mobile, land-based, whatever the stuff is sportsbook, we provide the software for it. Now, we don't run casinos ourselves. We develop software for a company. This company does the licensing to operators. So we're just a development house. So when I say player customization, what I mean is that we want to give players a good experience when they play the software. We want to make sure that if it's a player with a lot of money or a player that doesn't have a lot of money, they have a good experience. They get value for their money, they get value for the time that they spend on the system. And player customization is normally done with 2 core systems. The one is player segmentation, and the other one is player settings. Now, we do have some other systems that also help with the player experience, but a lot of them are plugged into the segmentation and the setting system. So player segmentation is a logical grouping of players into segments or groups. So what we do is for every single player that we have a list of attributes, about 80 or so. And this is things like his country, where he's from, date of birth, address, the number of deposits he's done, his play history, his games, etc., etc. The operators then use the English and SQL-like language to define rules. So they can say a player from Spain who's deposited, say, more than 5,000 euros in the last week, he goes into the VIP group or the VIP segment. A player that goes and registers a credit card, and perhaps that credit card has already been used by 5 or 100 other people, potentially that's a fraudulent player. So put that player into a bonus abuser or a potentially fraud segment. Now, operators are quite granular with these segments. Some of them might only have a couple of 100 segments that they use for their players. Others have up to 30,000 segments. So people move in and out of these segments all the time. And a player can belong to multiple segments at once. So you can be in 30,000 segments at any point in time. And now you've got rules to put people in groups. You also have rules to put people out of groups. So if a player is a new player and he just registered an account, you might put him in a new player segment. Once he's done something to prove that he's a real player, maybe done a deposit, sent through his ID, you'll then move him out of that into a validated player group. But in essence, segmentation is used for targeting players. The other one is player settings. So whenever you launch into our client, we need to show stuff on the screen that the player can interact with. This is things like the min bet, the max bet, the coin sizes, all the sort of stuff that you can configure before you click spin. That we have to send to the client. And then the player clicks spin or bet or play or whatever the case may be. Before we commit the transaction, before we do anything, we have to validate that what we got from the client is correct. Is it within the allowed range? Is it a correct value? This is to stop people that try to hack the client, or if there's any bugs in our software that sends through incorrect data. Now, for a game, it depends on the game how many settings there are. A very basic 3-reel slot might have 10 or 15 settings. But some of the more advanced 5 rule slots, or some of the Asian games like Pachinko can have about 120 to 150 settings per game. So these need to get checked per user, per game, for every transaction. But when I say there's settings, there's not one. There's actually quite a few of them. So when our game design team or the game studios release a game, they release it with default values. So they'll say, for this payout percentage, this is the recommended min bet, max bet, whatever the case may be. But operators want to customize that, because what we recommend might not be a good fit for the market that they're targeting. They might be in a market where the currency is quite strong, and they might be in a market where the currency is quite weak. So they want to adjust those values up and down based on the player currency. They can also adjust the value based on the segment that the player is in. So if the player is in a VIP segment, you might want to allow him to place much higher bets. Where if the player is a fraud player, you might want to limit how much he can deposit to limit the exposure that they can take you for. And then there's also other levels like regulated market. So our operators operate in markets which are regulated. So there's a lot of laws that govern what people can do. They might only be able to play for so many minutes in a day or deposit so much money in a week. So it's very important that these things are adhered to. So in the stack itself, there's about 10 settings or 10 levels in the stack, and we've got about 3 stacks. One for player settings, one for player game settings, and one for player deposit settings. So as you can imagine, you've got 30,000 groups, people moving around with that. You've got your hundreds of settings per game that changes every time, and it all needs to be done in real time. So our current implementation is a mix of SQL servers and C# and C++ services. We're a Microsoft house. We've used Microsoft stuff for quite a long time. So about maybe last year, June, July, I was given a team of 4 developers and said, please deliver our next player segmentation system. And these were some of the goals that we set out to do. We want to make better use of the hardware. Now, the SQL Server stuff, it works, but the problem is you have to plan ahead, and you have to know what the people are going to be using. You can't just scale out. So the operators that have 30,000 groups, that has a lot of movement, they have more beefy machines than the guys that have 100 groups with smaller movements. If the guys with 100 groups all of a sudden decide, oh, we want to do 30,000 groups also, they need to get upgraded hardware first. We also want to be able to make sure that we can scale elastically, and we want to make sure that all events are processed in real time. So those 80 attributes that we've got, most of them are processed in real time on the SQL Server. Some of them aren't. Some of them get processed maybe a minute or 2 minutes after the event has happened, which is fine, except for mobile users. For mobile users, you're not guaranteed the guy's going to be there a minute or 2 minutes after the event has happened. So everything for us needs to be real time. So these are the targets we set ourselves up. Every single installation of a software, we need to be able to support hundreds of millions of players. We want to be able to take our list of 80 attributes and extend it. So every week there's new requests for new features and new attributes they want to identify players on. Stuff like his hair color or his dog's name or whatever. We should be able to easily add it on and make it real time. And then the normal stuff you see on most software slides, 0 downtime, and we want to make sure we use modern software architectures and principles. So these are the technologies we picked for application tier: Microsoft Service Fabric and Microsoft Orleans. Now, Microsoft is probably not the first choice of technology for companies in the Valley, but we did some POCs, and these things are actually good platforms. So Service Fabric itself, it runs quite a lot of stuff in Azure, or Azure, as it is pronounced over here. Stuff like Azure SQL, Cosmos DB, all that sort of stuff is using Service Fabric in the backend. You can do a lot of things with Service Fabric. You can host applications in it, you can host containers in it, microservices, and it handles things like upgrades, failovers, etc. for you. So you just install your stuff on there, it takes care of the rest. And something that's very important, you can run it on-premise, you can run it in the cloud, or in a hybrid mode. For us, that's quite good. Regulated markets dictate that transactions have to be inside a certain region. So we can host our stuff on-premise, but if we need to scale out for whatever reason, we can just burst to the cloud when needed. So Microsoft Orleans, it's a virtual actor implementation. So actor software programming model. The Orleans team themselves put the actor in quotes because they don't refer to them as actors, they refer to them as grains. And that's purely just, there's a lot of white papers as to what the definition of a software actor is. And every week there's comparisons like, oh, this thing is meeting the criteria and the other one is not. So they're like, no, don't want to get into that fight. We're just going to call our stuff grains, and it's a virtual actor. It's extremely performant. We did load tests with Orleans versus Akka, and it outperformed it by 5 to 10 times in ping pong tests. And Orleans is also used by Microsoft quite extensively for things like Skype, for multiplayer games like Halo 4, Halo 5, and the Xbox team. So for those who don't know what an actor is, when it comes to the actor programming model, an actor is just a little piece of code that fires up, and it contains state and logic. So when the actor gets created, it loads its state from disk, or whatever your data store is, and you've got methods on the actor. And then as the actor methods get called, if the state changes, that state is persisted back to disk again. And then when you're done with the actor, you unload it. And then in the future, when you recreate the actor again, it loads its state off from disk, and it carries on as it was before. Now, you can create an actor programmatically, and you can remove an actor programmatically. You can also put a timer on the actor. So you can say, wake up every 5 minutes, every day, every hour, and do your work. So as you can imagine, if you have a whole lot of actors, all of them reading and writing state quite a bit, you've got quite a lot of high read and write throughput requirements on your disk system. And we have hundreds of millions of actors that store all the state for our players and all that stuff. So it's very bursty. We need something that can do that. So Microsoft Service Fabric, Microsoft Orleans, any guesses as to what our data system is going to be? So we tested SQL Server, we tested Redis, we tested Couchbase. Redis was the fastest. It outperformed Couchbase by about 20%, but it had problems. Under extreme load, after an hour or so, it corrupted itself. You shut it down, you bring it back up, the data store was corrupted. We're like, ooh, no thanks. It's eventually consistent, which for us was a non-starter in any case. So Couchbase looked good. Couchbase did a lot of nice stuff, but we weren't sure because this is a very core component to our system. I mean, setting is very much involved in every single bet that gets placed. This thing stops, the money print stops. So last year, Connect 2016, I was in the States for another conference, and I thought, well, while I'm here, because you know it's a 40-hour flight from South Africa to come to this side of the world, let me go and see what Couchbase is about. So I went to Connect, I met with some of the architects, the project managers, and the developers themselves, chatting between the sessions and chatting after everything. And they were very helpful, they were very passionate, and they were very excited. I mean, I'm just some random dude from the middle of Africa with these big dreams of hundreds of millions of actors, and it's all vaporware still. And they were so excited to help us. So I went back to the team, and I said, look, Couchbase is on board. They actually want to work with us to make this a success. So these are the standout features from Couchbase that we used. Now, some of these we knew up front, and we picked it. And some of these became more useful as the project came along. So strong consistency, CAS, sub-document, NIQL, and DCP. And I'll cover each one of them a little bit later on. But in essence, this is the architecture that we ended up with. We've got Service Fabric at the bottom, which is our application host. Then we've got our application itself in Orleans. And then Couchbase, which is our primary data store for our system. There's nothing else. And which is quite a big thing. And then in between the actors and the Couchbase system, we wrote a storage provider. So the storage provider is just the glue that ties the actor together to the Couchbase itself. So when the actor fires up, and it has to do something like load its state or write its state, it goes to the storage provider. And it's in the storage provider where we were able to take the power of Couchbase and marry it to the power of actors. So that's why we say that Couchbase is a very good fit for modern programming systems like actor frameworks. So consistency for us was the most important thing. Couchbase is strong consistent, unlike Mongo and Redis, which are eventually consistent. For us, if a player logs in, it's a VIP player, he needs to get VIP treatment. It shouldn't be, oh, we think he's a VIP or not. Same thing for a fraudulent player. If a fraudulent player logs in, we need to treat him as such and restrict what he can do. Couchbase also has replica reads. So if for some reason there's issues with our Couchbase cluster, which is hosted in Linux, not on Windows, we can still get the data from replicas, so application is still working. And Couchbase is extremely fast. We were doing benchmarks in the cloud with not even high-spec hardware, small clusters, and we were able to do a couple of 100,000 reads and writes per second without any issues. So for us, that fitted the whole bursty nature for actors quite perfectly. The next thing was the CAS value. So for those who don't know, CAS value in Couchbase is like a version number that's attached to every document. So when you update the document, the CAS rolls up to the next number. So in this case here, Couchbase has a doc, that could be anything. The actor loads it up. Couchbase says the version of doc is 2. The actor has the state and the version number of 2. Now, because it's a distributed system, there is a possibility, very unlikely, that you end up in a split plane scenario, where you have 2 actors that actually point to the same document. Normally that's not possible, but if you have a network partition, your system can be split into 2. In that case, we've got 2 actors working independently of each other, pointing to the same Couchbase document. So far, it's okay. What happens now is the one doesn't update. It does a state change. So it goes to Couchbase. Couchbase says, thank you very much. I had version 2. You've got version 2, so we can go to version 3. The other one is still on the old state, the old version. When it tries to do an update, Couchbase says, sorry, there's a CAS mismatch. You've got version 2, I'm already at version 3. So what our actor does at that point, it just unloads itself. Because it knows I'm supposed to be the only one doing the work, but someone else has now done state changes for me, so I'm just going to destroy myself and let the other one carry on with the work. That way we get consistency in application the same way that we can get consistency in the disk. The other one is sub-document operations. So we've got a lot of attributes, like I said, 80 or so. We don't want to read the whole document every single time we'd have to do a change. So when the player does a spin, the player does a bet, or whatever the player does, we don't want to read that into a system, do the changes, and write it back again. With the sub-document changes, we can just target the one that we're looking for, like login events or purchase history, and we can just append the one we need to do. It saves a lot of network traffic, and it's really, really, really performant. So NIQL, for us it was very familiar, very easy to use. Because we are very SQL-based in the past and still is, SQL is very familiar to us. We're very strong on SQL Server. So it took us about a week or 2 weeks just to understand the new stuff that NIQL introduces. Because now you work with JSON documents, it's not schemas. So NIQL has a few extra constructs that you have to wrap your head around. But yeah, after about 2 weeks, we were doing some pretty advanced querying and indexing and stuff on our Couchbase cluster. And NIQL is very performant. We can't index for everything because it's not, the operators are the ones that set up all these rules. So it's impossible for us to index for everything that they're going to do. So we do a best of index, and for most cases, NIQL performs quite fast. There are some cases where we can't index it exactly as how the operators write the queries, where it's not so fast, but then you are scanning through almost 1 billion documents. But there's a lot of stuff in Couchbase 5 that makes it better. But the one nice thing about NIQL is it allowed us to split our data between hot data and cold data. Now, since we started in the mid-90s, that's what, 24 years of play information. We don't want to keep all that play information in memory. We can, but it's going to be a waste of hardware. Some of the players might not be coming back. Some of the players might have moved on to other accounts. There's a lot of superstition in casinos and stuff too. So, the player might think it's an unlucky account, so he goes and creates another one that's more lucky. So what we do is we give operators a choice. And we say 6 months, a year, 2 years, whatever the period is, those people will keep in memory and we'll work on them. However, when you're on a segment or do stuff on players that's outside the range, we'll just use NIQL to go and quickly find those players, load them into RAM, do the work that's supposed to do to them, and write it back to disk. So for us, that's actually quite cool and quite efficient. Now, about 8 months, 9 months into the project, we now needed to start delivering into our reporting framework. So we've got a lot of reporting stuff we do. There's BI, there's analytics, there's data science, a whole lot of stuff. With SQL Server, it's quite easy. You just slap transactional replication on top of the database, and you've got your data there in some form or another. And it's ordered and it's sequenced. With Couchbase, we couldn't do that. There are stuff that exists for Couchbase, like sync gateway and all the other sort of things, but it wouldn't work for us. Our documents are structured as state for the actors. So for us to take that and convert it into a report, we need to enrich it, we need to do a lot of stuff to it to get it into a format that the reporting system will understand, which we couldn't do with off-the-shelf stuff. The one option we looked at was Rabbit. We've got quite an extensive RabbitMQ infrastructure already, which we use for event notification. So we thought, well, what if we just publish an event to Rabbit, have a subscriber app that will just take it off the queue and then put it into the reporting database for us. It can work, but it won't scale, because we need to make sure that the sequence, everything happens in the order that's supposed to be. If you do a insert into a group and say delete from a group, if you get it the wrong way, you might do the delete first and then the insert. So the report will show it incorrectly. Now, the only way to guarantee order with RabbitMQ is to have a single publisher and a single subscriber, which is not going to scale. Our system can publish between 1 million to 10 million events in a minute. So the little single subscriber, it might take minutes or hours to actually catch up. And if we now go and we add multiple parallel subscribers, we'll lose ordering completely. So Rabbit was out. Then we dug around a bit more, and we saw that Couchbase has this nice DCP protocol, which is the database change protocol. And Couchbase internally uses DCP for node communication. When you update the doc, the DCP protocol tells the index node, this is a doc that was changed, this is the changes. It's used for the cross-site replication. It's quite core to how Couchbase actually works. And there are connectors that exist from Couchbase for things like Elasticsearch and Kafka and Cassandra, which allows you to take your stuff out of Couchbase in order and sequence and put it into your data store. The problem is we don't have any of that sort of stuff. We don't have Cassandra and all the other sort of stuff in our infrastructure. And if we go to our IT department now and say, please give us a Cassandra cluster, but it's okay, we just want to put a document in there for a millisecond and then read it out, it's going to be a bit of a waste. So we did the next best thing. We wrote our own DCP client. We first started with doing a one-to-one port from the Java clients. After about a week or so, we said, no, bad idea. There's a lot of stuff in Java that doesn't translate completely to C#. Things like futures and the way they do threads. So we said, scrap that. We started again, and we wrote a native C#.NET DCP client. It took about a month or so to get done. We are currently in discussions with our CTO and our many, many lawyers to try and open source this stuff to give it back to the community. Because there's probably some other .NET houses out there that could use it. So these are some performance stats from LNP and from production. We're able to do more than 1 million player setting requests per second, and then our system is sitting at about 10-20% CPU usage. So we're underutilizing the hardware, oddly enough. From Couchbase itself, we are seeing sub-millisecond reads for the majority of the time. So when we need to load people into memory or do the active hydration, it's super quick, it's super efficient. And all our events are now real-time processed. So all 80 of them, and however many more that's coming out, real-time. And we're cloud burstable. So Service Fabric itself, you can host on-premise, you can burst to the cloud as needed. We do the same with Couchbase. We host the cluster on-premise, we just add nodes to the cloud, rebalance to it and do whatever needs to be done to make it work over there. So for us, it's fantastic. So from our side, we work quite closely with Couchbase and also 9th-bit. 9th-bit is the Couchbase partner in South Africa. And they've helped us quite a lot with implementation reviews. They've helped us quite a lot with infrastructure reviews. And they also sent some guys out to us to do some on-site training for a week or so, which was actually quite nice. So yeah, I just want to say thank you to Couchbase. It's a fantastic product. It really is something that enabled us to take our customization of casino players to the next level. And it really is a fantastic fit for modern software architectures like active frameworks and the like. Cool, thank you.